In this video, we are going to discuss solving proportions. A proportion is an equation that states that two ratios are equal to each other. For example, 2/3 equals 8/12. These two fractions are equivalent of each other, so their ratios are equal to each other, which creates a proportion when we have one ratio equal to another ratio. In every proportion, the cross products will always be equal. Cross meaning diagonal, and product meaning multiply. So as we look at one diagonal of 3 and 8, the product of 3 and 8 is 24. And as we look at the other diagonal of 2 and 12, you will see that that is also equal to a product of 24. This will always be true, and this property is useful when we are solving for missing variables included within a proportion. For example, the proportion of 7/12 equals 49 over x. One way we could solve this proportion is seeing that our numerators are increasing by a growth factor of 7, so that would also mean that our denominators would increase by a growth factor of 7. Another way to solve for this missing variable would be to set the cross products equal to each other, because we know that that statement is always true. One diagonal would be the product of 12 and 49. I could also write that as 49 times 12. I'm then going to set that equal to the other cross product, which is 7 times x. My first step is to multiply 12 times 49, which I get a product of 588. And then my last step is to solve this equation for the missing variable x using inverse operations. And this gives me a value of 84. So that tells me that this missing variable included within this proportion is equal to 84. Sometimes our proportions include more than a single term within the numerator or denominator. So it is not as easy to see the growth factor or rate amongst the numerators and denominators. This is where using the cross products is going to be helpful. One cross product within this proportional is 3 times -4. I'm going to set that cross product equal to the other cross product. It is very important in this second cross product that I make sure I take 7 times all of the other numerators. So I'm going to group that numerator together within parentheses. 3 times -4 is -12, and then I need to make sure that I take 7 times each piece included in that numerator. This gives me 7x minus 14. Then I have two inverse operations to use to solve and get x by itself. This leaves me with a value of 2/7. And just like any equation, I would be able to take this value of 2/7 and plug it in for x and see if I get two ratios that are equivalent to each other in a true equation. So I still am able to check my answer. Here we have a variable in the numerator and the denominator, but my process is not going to be any different. I'm still going to set my cross products equal to each other. So in one diagonal, I have 3x times 8, and in another cross product, I have 5 times all of the quantity of 5x minus 1. So I'm going to put that entire numerator in parentheses to make sure that I take 5 times all of the other numerator in that diagonal. 3x times 8 is 24x. And doing the distributive property to multiply this 5 times this difference gives me 25x minus 5. In this equation, I have variables on opposite sides, so I'm going to move them to the same side using opposite operations. So I'm going to subtract 24x from both sides of my equation. This cancels out on the left-hand side. Since there are no other terms on the left side of my equal sign, I do need to write the value of 0. And then I have one inverse operation left to get x by itself, because 1x is the same thing as x, and this leaves me with a value of 5. If I would like to check my answer here, I could plug this value in for x in both these spots and see that I have a ratio that is the same as 8/5. Plugging 5 into the numerator and the denominator in place of x, 5 times 5 is 25, so this leaves me with 24 over 15. And I will be able to see that if I take a 3 out of both this numerator and denominator, I am left with 8/5, which is equal to the other side of my proportion. Sometimes the x's may be included on different sides of the equal sign. Once again, our process is going to be the same. We're going to set our cross products equal to each other. So in one cross product, I have 3 times the quantity of x plus 3, and setting that equal to the other cross product, which is 5 times the quantity of x minus 2. Once again, it does not matter which diagonal you write on the left side of your equation or the right. In this equation, I'm going to have to do the distributive property on both sides of my equal sign. And this leaves me with the result of 3x plus 9 equals 5x minus 10. Once again, I have variables that are on opposite sides of my equal sign, so I need to use opposite operations to combine them. Moving them to the right-hand side where there are more x's will allow me to keep my x coefficient positive. Then I have 2 inverse operations to get x by itself, which leaves me with a final answer of 19/2. Many things in real life grow proportionally and at the same rate. In this example, a portable media player has 2 gigabytes of storage and can hold about 300 songs. So this means that for every 2 gigabytes of storage, there are 300 songs. In my other media player, a similar but larger one, it has 16 gigabytes of storage. So I'm going to set up my proportion in the same order, using 16 gigabytes on the numerator since I chose to put gigabytes on the numerator of my other ratio. I'm now going to solve for how many songs the larger media player can hold, so that is where my variable will be sitting. Once again, I can use growth factors or cross products to solve. One way would be to see that this growth factor is multiplied by 8, so I can take 300 times 8 to find that missing variable. Another way would be able to set my cross products equal to each other, and I have the product of 316 and set equal to the product of 2 times x. So my first step would be to take 300 times 16, which gives me 4,800, and set that equal to 2 times x, and have one inverse operation to get x by itself, which leaves me with 2,400. And remembering that I am finding a number of songs, so this media player would hold about 2,400 songs.